A variable is a symbol that represents a number. Now, I know so many of us tend to get so super confused about variables, but really, variables is not something new to you guys. Think about when you were doing sums that look like this. This little block over here, it is a variable. It is a symbol and it represents a number. The only thing that's different now is that now instead of having a little block, what we do is we put in a letter and now you have to solve for the letter. So that is what Sunny exams tomorrow. Good luck. Um, that's nice, Itanili. You get a nice long break now. Okay, so that's a variable. Looking at a coefficient, super simple. It's the number in front of a variable. Now, I want to ask you guys, if I have a number and I have a variable, what is the operation that's actually being done here? %, Umar. When we have a number in front of a variable, that operation really is multiplication, and maybe I should write x like that. 100% pre, it is multiplication. So important that we know that as well. A constant is just a term that stands alone, so a number that stands alone, so no variables. That is a constant. Then we have a term. A term is a combination of coefficients and variables. Now, when I talk about coefficients and variables, it's something like 2xy squared over 3xy. This whole thing over here is one term. And how do we identify terms? When we have an expression is when we have a collection of terms. And how do we identify these terms? The terms will be separated by addition or subtraction. Now, super important, we ignore any addition and subtraction that are locked inside of brackets. Yeah, so we ignore those addition and subtraction signs. But something like this, there is no addition and no subtraction in this whole thing, meaning it's all one term. Okay, so that is that. And then we have lastly an equation. When we have an equation really is just a statement that two expressions are equal. So if I have an expression that looks like this, and then an expression like 36 plus x, I have two different expressions. And now when I create an equation, I am making a statement and I'm saying these two expressions are equal to each other. And once I do this whole thing creates a new type of sum called an equation. Okay. So this is our terminology. Now, when you're in your test or in your exam and you're like, okay, wait, is this an expression or is this an equation? When you have an equation, your instruction is going to be solve. But when you have an expression, your instruction there will be simplify. So that's another way that you can tell the difference between expressions and equations. Now, let's just use some reactions. Are we all comfortable with this terminology? Good. Super, super important that you guys are able to define all of these words, that you're able to use them and identify them. So I'm glad to see thumbs ups. Let's now look at specific rules when we're dealing with expressions. When we are dealing with expressions, we get very specific rules. And the most important thing to know when we're dealing with expressions is we must know what like terms are. Now, remember, we did learn about what like terms are, but like terms are terms, and we already spoke here about what a term is. So like terms are terms that have the same variables and the same exponent. So important also to know that your coefficients do not have to be the same. For example, they are couples. That is a good way to look at it. For example, something like 2x, 5x, 6x. These are three separate terms over here, but they each are like terms because they have the same variable of x. So if you look at it, they all have the same variable of x, and they have the same exponent of that invisible exponent of 1. And so these are like terms. Now, what I want to ask you guys is, uh, plus 7. Are these like terms? Do we have like terms over here? Shady saying yes. Uma is saying yes. Any other body? Any other body? My gosh. So they are like terms. What about something like, let's say we had something like this. Are these like terms? Uma saying yes. Unat is yes. Zach is saying yes. And you guys are correct. Now, what about something like this? Are these like terms? 100%, you guys. These are not like terms. And it's important that you guys are able to identify that these, although they do have the same variables, which is a and b, they don't have the same exponents. And so because of that, these are not like terms. Good. I'm super happy to see that you guys are up to date with your work. Now, why is it important that we know what like terms are? Because like terms can be added, but unlike terms cannot be added. Also important is that when we do add like terms, our exponents do not change. Okay? When do our exponents change? Our exponents will actually change when we apply. Our exponents will change when we apply our exponent rules. And my exponent rules will only apply when we are multiplying or dividing terms. So that's super important. In an expression, if you're adding or subtracting stuff, you are applying your like terms rules. Okay? If you're multiplying and dividing, you are applying your exponent rules. And when we apply our like terms, or rather when we apply our like term rules, our exponents don't change. Okay? So the only time our exponents will change is when we're multiplying or dividing using our exponent rules, and then our exponents will change. So very, very important as well that you guys remember this, because if you see something like 2x plus 6x, so many of us are making this mistake of saying this is 8x squared. No, 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 no. Do not do this. We are adding, oh, I don't know what I did. We are adding. Because we are adding, we are applying our like terms rules. And if we're doing like terms, our exponents should not be changing. So you can't all of a sudden start getting a squared when there was no squared before. Okay? So I hope that you guys know this and are familiar with this. But if not, that's what we're here for. We are going to practice a lot of sums. So that's it. The only time now my exponents are going to change is if this was multiplication. The minute it's multiplication, then we can change exponents. But for now, let's just move on with our theory. There are also specific rules that we are going to apply when we have our expressions. So the first thing you always want to do is, if there are brackets, you want to distribute. So you don't want to keep those brackets. Always distribute so that you remove your brackets. The next thing you want to do is you want to identify the terms in your expression. So once you've removed your brackets, you should get a whole bunch of different terms in your expression. And what you should do is, if you can, you are going to fully simplify each term on its own. Meaning, if a term has division in it, if a term looks like this, we can simplify this term. We can remove our fraction line, or we can do the division. We can apply exponents rule here. We can simplify this term. So if you can, you are going to fully simplify each term on its own. And once you've fully simplified each term, then you are going to go in and you are going to add like terms. So I really just highlight everything just so you guys can see what I'm referring to. So I'm just going to erase all my highlighting at this point. Okay, and then here is a recap of our exponent rules. I'm not going to go through them, but have a look at them, guys, and refresh your mind. If you do need a recap, go back. I'm actually not sure when we did it. I think term 2. Yes, it was term 2. Go back to our term 2 videos and go and have a look at the videos for this. Cool. So now that we have done all of this theory, let's get into some expressions. And sorry, I actually have the chat not open. Let me check if anybody has said anything in the chat. Um, okay, yes. So that is going to be that. When we're looking at this, we don't have brackets, so we don't have to distribute. I need to now identify my terms. I want you guys to tell me how many terms are in this expression. 100%, it is 3 terms. Now, if I look at what my terms are, this is my term, this is a term, and this is a term. Can I answer, or can I simplify any of these terms more? Can any of these terms be simplified on its own? Unati is correct. The answer to that question is no. So what I'm going to do now is I need to identify like terms. What I'm seeing is they all have this variable of x with that invisible exponent of 1. So these are all like terms. And so what I need to do is I need to say, okay, -3 plus 5 is going to give me +2. +2 minus 1 is going to give me 1. And so my answer here is 1x. Or we don't even have to write the 1. And you can just have your answer as x. So Bree, your answer there is 100% correct. Now let's have a look at a different question. What about now? Now I'm going to make our lives easier, and when we don't have brackets, so we're not distributing, we can't simplify any of our terms on its own. So what I want to hear from you guys is how many terms are in this expression, which terms are like terms, and what is my answer going to be? Six terms, 7 terms. Let's count. So I'm just going to highlight them all right now. We have 1 term, 2 terms, 3 terms, 4 terms, 5 terms, and 6 terms. Okay, so there are 6 terms. We know how many terms. Remember, Liaho, what we do is we literally say, okay, my terms are separated by pluses or minuses. So I'm literally going to circle my pluses and minuses, and I'm going to now count how many numbers or terms are in between. 1, 2, 3, 4, 5. Oh my gosh. Did I count wrong the first time? 1, 2, 3, 4, 5, 6. Oh no, there's 6 crosses. I just counted wrong the second time. I was like, am I going crazy? No, there are 6 crosses. So 6 terms. I see Shady saying 2 pairs of like terms. Well, let's erase all my nonsense here. And let's have a look. I see this x squared. This is not 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 x squared. This is x squared. Then I also see just a normal x. This is not x. This is not x. This does have just a normal looking x. And then I see constants. Now my constants are another set of like terms. And so we actually technically have 3 sets of like terms. So what we are going to do is 11x plus, or rather 11 plus 13 is going to give us, as Brie has given us the steps I see, 11 plus 13 is going to give us 24, but not just 24 anything, 24x squared. When we're dealing with our x's, it's negative 8 minus 7, which gives us negative 15, and not negative 15 anything, negative 15x, and then negative 11 plus 1, that is going to give us negative 10. And so this is as far as I'm going to go. Once I don't have any like terms in my final step, that's when you know you're done. You can't simplify any more than that. So I want to ask you guys, are we all understanding how we got to this answer? Is it making sense? Do you have any questions? Okay. Thumbs ups from our 3 guys, Zach, Liaho, and Umar. I actually didn't check who's in here, but I don't know if there are any other guys. Entle, I see you're in class. You missed your story. I'm so sorry you fell backwards and got mad at the floor. Okay, so that was that. Let's now do another one. Good luck, Zach. Let's look at a different one. I'm gonna go down a bit. So we have something like this now. Does anybody wanna maybe raise their hand and tell me how to do this? Because I'm a little bit confused. Nobody wants to teach me today? I see you saying distribution. So I have to multiply this by this and this by this. But now I'm still confused because what the heck is the answer to 6y cubed times 2y squared? How do I do that? Is that Unati? Unati has had mercy on me and is coming to help me. Yes, Unati.
Ma'am, I'm asking a question about 1.2.
Okay.
Is there like no definite answer? Is that the answer?
Yes, this is the answer. So remember, when we have expressions, our instruction is never going to be to solve. Because when you have an expression, you can't get to a definite answer. The only thing you can do is simplify. Okay.
Yes, ma'am.
So this is as simple as we can get it. When we have no like terms, no multiplication, no division, there is nothing else we can do. So when you have an expression, your instruction is to simplify because you're never going to get a definite answer. What you are going to do is get a simpler answer, but you're not going to get an answer with there that tells you x is equals to 6. Does that make sense?
Yes, ma'am. Thank you.
Pleasure. Um, Okay, so that was that. I'm still on my own though. Uma is helping me. Let's see. Tyra, do you have a question or are you helping me?
Ma'am, can I please give the answer? I'm not quite sure, but yeah.
Mm-hmm. Mm-hmm.
Okay, you say negative 6y to the power of 3 times 2y to the power of 2.
Mm-hmm.
Then you get negative 12y, 3 neg- negative 12y, then 3 plus 2 as exponents.
Mm-hmm. Beautiful. And
Then
if we simplify that more, what is 3 plus 2?
5.
Thank you. So that was well done. But now I still have to go negative 6y cubed times negative 3. How do I do this one, Tyra? Oh, you just helping me with this one.
Ma'am, you just say negative 6 um times negative 3, you
Mm-hmm.
get 18 to the power of 18y to the power of 3.
Beautiful. Okay, so you guys have helped me. Thank you very much to Tyra and Uma. You guys have helped me. So we have negative 12y to the power of 5. Brie, I also see you not raising, sorry. I also see you answering in the chat. And we also get positive 18y cubed. Now, guys, when you're doing multiplication like this, the trick is to always do SNV. Multiply the signs first. That's what my S stands for. So it's a negative times a positive, which is going to give me a negative. Multiply your numbers next. Negative 6 times 2, which is going to give me 12. And because we dealt with our signs in the beginning. We don't have to worry about signs when we're worrying about numbers. So you can just say 6 times 2 is 12, and then worry about your variables last. Y cubed times y squared, exponent rules, and that gives you that. Okay. So always use SNV when you are in doubt about how to multiply or how to divide. You are going to multiply signs first, then multiply the numbers, then multiply your variables, add it all together, and you will get your answer. Cool. So that is that. Now, what do I do now? Do I have like terms? Can I add stuff? Can I simplify stuff more? What am I going to do here? It's Andile saying leave as is. We have an add and we have nope, you can't go anymore. And Tyra, I want you to see we can't add because we don't have like terms. Okay, I am done. You're done. Bree is telling me I'm done. So we have y over here to the power of 5. But here it's a different exponent. So because it has this different exponent, they are not like terms. I can't add. I now have this expression over here in the step where there's no multiplication, there's no division, and there's no like terms. And when that happens, we are done. Brembreck is almost here. And let's just move this up a little. Okay. We are looking at 1.4, and I don't want you guys to see that last one. So what do we do now? Okay, I see brackets. I know what you guys are going to tell me. You're gonna tell me distribution, which is fine, but I don't know how to distribute. I don't know why I'm taking this approach today. I'm just acting like I know nothing. Obviously, I do know how to distribute. I just want you guys to tell me. It's because I was sleeping before this. Sleeping makes me weird. Sleeping during the day makes me weird. Okay, so I know you're gonna tell me distribution, but like I don't know what to do here. So I see I'm gonna have 3 times x. I see I'm gonna have 3 times 3y. I see I'm also gonna have 2 times 2x, and I see I'm gonna have 2 times negative y. How do I do these things? How do you not know? You're the math teacher. Yeah, you know my nap, Shady, my nap took away all my knowledge. So now I'm like counting on you guys. I'm hoping that I taught you guys well enough so that you can reteach me. I don't know. Somebody give me the answers. I'm like that one kid in the test that doesn't know anything. I'm asking everybody for the answers. Yes, Brie.
So 3x times x is 3x,
Mm-hmm.
and then 3 times 3y is 9y,
Mm-hmm.
and then we're gonna have 4x.
Mm-hmm.
Is this one going to be negative 2y?
That is correct.
And then we're gonna say 3x plus 9y
Mm-hmm.
plus 4x
Mm-hmm.
minus 2y.
Mm-hmm.
And then we're gonna group our like terms, which is 3x plus 4x.
Mm-hmm.
And then we have 9y and negative 2y.
Mm-hmm.
And then 3x plus 4x is 7x.
Mm-hmm.
9y minus 2y is 7y. So it's positive, it's plus 7y. And with that,
Thank you very much, Brie. You were the first person who has actually put me out of my misery and just answered.
you're
So
welcome, man.
that was very well done. Thank you for answering. And Brie has taken us to the exact right answer. She's done a beautiful job. She's explained the like terms. Yeah, my job here is done. The teacher has become the student. Let us look at our last one before our brain break. I think our last one before our brain break. Okay. Now, this one, don't even ask me about this one because this one looks hard, right? This is a fraction. I hate fractions. I see negative numbers. I hate negative numbers. I see exponents. I hate exponents. Itandile, are you gonna help me?
Afternoon, ma'am.
Afternoon.
I think so, ma'am.
Itandile, sorry, what did you say? I didn't hear that.
I think so. I am gonna help you, ma'am.
Okay, you think so? Let's go.
Can I break the fraction though, ma'am?
You can.
So, ma'am, it's negative 3x over negative 3x plus,
So remember it's x squared.
yes, ma'am, plus 9x to the power 4 over negative x squared.
Remember negative 3x.
3x squared.
So when you break up a fraction, your denominator must still stay the same for all the fractions you create. Does that make sense?
Yes, ma'am.
Cool. Now what?
So, ma'am, negative 3 divided by negative 3, ma'am, is 1, so it's going to be x 2 minus 2 plus negative, so it's going to be is x 2 minus 2 plus negative 3x 4 minus 2.
Beautiful.
So, ma'am, in our equation, 2 minus 2, which is going to be 0, so, ma'am, we're going to be left with x to the power of 0 plus negative 3x to the power of 2. Please bracket, ma'am, the negative 3x cubed. Thank you. No, ma'am. Then I'm going to say x is equals to, x minus 3x cubed. Or, ma'am, are we going to leave it as negative 3x cubed?
Okay, so the first things first, I want to remind you this is a square.
Squared, ma'am.
And we can, so what you want to do is multiply out this positive and negative.
Yes, ma'am. So it's going to leave it as a negative x.
So negative 3x squared.
Squared, yes, ma'am. Ma'am, isn't our final answer going to be negative x?
Tell me how you got negative x.
Ma'am, because sorry, isn't ma'am because our exponent is 0, so it's going to be 1.
Okay, so let me explain what is happening. This is one term by itself. So you are 100% correct. Anything to the power of 0 is going to be 1. Okay? But this term is equals to 1. It does not mean that now all the terms in my expression is equals to 1. So what happens, Itandile, is I still have this term over here of negative 3x squared.
Yes, ma'am.
So what now? Can I simplify more?
Yes, ma'am.
Okay, how?
It's going to be negative 2x to the power of 2.
So you're telling me these are like terms?
No, ma'am.
There you go.
Probably because I'm sick, ma'am, I got the wrong answer. Probably because I'm sick.
No, you didn't get the wrong answer. This is it. You just can't simplify it any more than that.
Ma'am, I'm sick. No ways. I think this is why I'm sick. No ways, ma'am.
You did well, Itandile. Thank you for answering.
It's my pleasure.
Okay. Uma, can't you cancel out the negative 3x squared in the fraction? So that's basically what we did. We basically canceled this out and we canceled this out. And what we could have done from the beginning, right? So we broke it up. That was good. We broke it up, negative 3x squared plus 9x to the power 4 minus 3x squared. So what we could have done is we could have said, okay, this is basically the same number divided by the same number, which we know is going to give us 1, plus over here, cancel out 9 because 3 goes in there 3 times. 3 goes into itself 1 time. Cancel out the x squared. Cancel out this and make it 2. But what we're still left with, Uma, even though we've canceled, we're still left with the negative over here. We're still left with the 3, and we're still left with the x squared. So that's why we still have this negative 3x squared. Okay, so I hope that makes sense, Uma. We kind of did cancel out the denominator, but what was left was still negative 3x squared. which just left us with what we had here, 1 minus 3x squared. Okay. Now, I want you guys to use some reactions. Let me know, how did we feel about this? Does this make sense? Okay, good. I'm glad to see that, and I hope you guys are not lying to me so close to your exams. Okay, we'll leave that one and that one for after the brain break. Let us move on and do one must. Oh, yeah, one must stay. So we are only keeping one. We're getting rid of everything except one. So let us look. We have Itandile's hand up. Itandile, you get like 10 seconds. Okay. Tell me what you are keeping.
Ma'am,
Mhm.
I know people are gonna hate me, but then listen, bruh. Because ma'am, Doritos are expensive, Pringles are expensive, Lay's are now expensive.
I feel you. Okay, good choice. Um, Personally, Pringles are like insane to me. You get like 5 chips and you pay like 50 Rand for it. What is wrong with you guys who are keeping Pringles? Like, I just can't understand it. Okay, Liajo, what is your thing that you're going to keep?
Ma'am, it's definitely gonna be Doritos, ma'am. Doritos are definitely yo. I'm struggling today, yo, ma'am. I'm tired, yo. But ma'am, Doritos, ma'am, are definitely the best, ma'am. Definitely the
Okay,
best.
I see
And
that.
Lay's, ma'am, the average. Simba, ma'am, nah. I hardly eat them, ma'am. And Pringles, as you said, ma'am, like yeah. But Doritos are definitely the best, ma'am.
Okay. Liajo likes Doritos. I think Lay's is like great. The dark green Lay's and the orange Lay's, unbeatable. So I'm keeping Lay's. Y'all are not South African, yeah. And that's the other thing, Uma, whose hand is fitting all the way in to that freaking Pringles cylinder thing. Okay, Unati, you can do the next one. We are keeping one. Sorry, I'm trying to move this down. Lollipops, Jawbreakers, Fizzes, Chappies. Which one are you keeping?
Ma'am, I might have to keep the lollipops.
I
have
was thinking the same.
because
You
like
have a
breakers
reason.
are like they take too long to eat. Fizzes, you get bored of them, and then chappies, it eventually becomes like too hard to chew. So
Feel
yeah.
you. Yeah. Okay. Yeah. First pops, I don't know. These are like the OG suckers for me. Love, love, love them. Um, so I get that. But also these jawbreakers, especially these cinnamon ones, these like fireball ones, these are so good to me. So I think personally I might keep jawbreakers, but just for these fireball jawbreakers. Itandile answered. Liako answered. We have Josi. Josi, what is your take? Okay, Josi, while you're figuring out how to talk, you can still answer. We're just going to take Shady in the meantime. Shady?
Ma'am, how do you enjoy jawbreakers? Like you're going to be on
No,
that
ma'am.
thing
Okay,
for
I
like
think
five
that,
hours, and then only after you're gonna ma'am, no, that's too
but
much.
it's not the huge jawbreakers, you know. It's like these little ones that are fine.
Ma'am, okay.
Shady just put up her hand to fight. Okay, Josi, yes, I think I heard you talking.
Ma'am,
Mm-hmm.
I also say lollipops because like some of them come with chappies.
That's true. That's smart. You're
Ma'am.
you're thinking like two in one.
Yes, ma'am. Logically, ma'am.
Makes sense. But also jawbreakers also sometimes come with chappies in the middle.
But ma'am, lollipops, ma'am, come with. Ma'am, can't compare, ma'am.
Okay. Fair enough. Fair enough. That was a smart play. I didn't think of that. But good decision, Fossey, and thanks for answering.
Yes,
This
ma'am.
one, I very specifically, I don't know why. Sorry. Um,
Ma'am, I have a question. What are
yes.
jawbreakers?
Oh my goodness. It's a delay. I'm gonna have to ask you to Google. I'm not about
I'm
to.
very sorry, but I don't know what a jawbreaker.
Oh my gosh. It's basically just like a super huge candy sweet. Like think of like an Astro, you know, those like candy coatings. Think of an Astro but with like 100 candy coatings. That's basically what a jawbreaker is. And now I don't know why, but I very specifically remember Liaho answering this one when we were doing it as one must go. I can't remember what Liaho picked. But I'm curious, Liaho, what would you keep if you had to only pick one to stay?
Yeah, ma'am. Ish. Yeah, ma'am. I'm South African, ma'am. So it's gotta be pop, ma'am. Cause pop, ma'am. Yo, my mom cooks it nicely, ma'am. I have to say, ma'am. Rice is good, ma'am. But ma'am, I remember when I said like one must go. I forgot which one I picked.
I
What
also
did I
forgot
pick?
which one you
I
picked.
think I picked bread. I think so. Ma'am. I
Okay.
think yeah, it's bread. But ma'am, pop, ma'am. Even ma'am, like everyone in the chat, ma'am, is saying
I
pop.
see. The
So,
consensus is crazy.
so
Everybody is
ma'am,
picking pop.
it's definitely pop, ma'am. It's definitely.
Okay. Fair enough. Uma, did you want to answer?
Pasta, ma'am. Pasta.
Why pasta?
Italy, and the flavoring of pasta is nice,
I agree. I love pasta.
especially
Um,
with like grated cheese and stuff like that.
mm, same. I'm stuck between pop and pasta. Um, this is essay. You know, it's actually crazy to me, you guys. I have relatives who have like never eaten pop ever. I'm like, what are you talking about? What do you mean?
They South African, ma'am. They should try it.
That's what I'm saying, right? I'm like, what do you mean? But yeah, crazy. Okay, cool. Yeah, I don't know. I'm stuck. I actually don't even know because I like all of these things. So who knows?
Same, ma'am. But pop is better.
Back to maths. What I want to show you guys here, we're not gonna do it. I'm just gonna talk you through it. What we would have done over here is we would have gone and cube rooted each coefficient and each variable separately. Now, when you are cubing something, really all you have to do is when you have these variables, all you have to do is go take the exponent and divide it by 3. And then that will give you your answer. So 15 divided by 3, you would have gotten x to the power of 5. Y to the power of 12. If you divide it there, you would have gotten y to the power of 4. And you guys should know the cube root of 64. Okay. So looking at the next one over here, what you would have done is you would have to simplify underneath your square root first. So these are like terms underneath my square root. So you were gonna subtract these like terms. You would have gotten now one term underneath, and then you would have done the same thing that we did up here. Okay. That's that. On to equations. Now, remember, guys, we did equations this term. So this is super important. And even when you're doing geometry, for those of you who are writing your paper 2 super soon, our equation rules are super important to remember. Now, always when you're doing an equation, remember the big picture. The goal of an equation is to get the variable by itself on one side. So anything you do when you're solving an equation, anything you do should be to get the variable by itself on one side. Also, guys, let's not come for people in the chat, please. Let's let us focus back now over here. So steps, very similar to expressions. If they're brackets, we're going to distribute. If there are fractions, this is a different rule now for equations. If there are fractions, you are going to get all of the terms in the equation to the same denominator. Once all the terms have the same denominator, you can drop the denominator. Okay? Then once you've dealt with that, you're going to move all the terms with your variables to one side of the equation. Add like terms if you have multiple terms with variables in it. Then you are going to remove coefficients and exponents by using inverse operations. So remember, coefficients, they basically mean multiplication. So the inverse of that would be division. Where you have exponents, the inverse of an exponent is a root. And remember, whatever you do on the one side of the equation, you must do on the other side of the equation. And that, once you follow all of these steps, they will bring you to your answer. And once you get it, you can always check your answer. So you substitute the answer you got into your original equation and make sure that it actually works. Cool. So let us look at 2.1. Now for 2.1, we are going to do our shortcut. Instead of adding 40 on this side and then adding 40 on this side and then cancel, and now we have plus 40 on this side, we do our shortcut, which is just to say we transpose this term over to the other side. That becomes x equals to 5 plus 40, and x is equals to 45. Thank you, Uma Tyra Itandile. Let us look at another example. So over here, oh, now I'm a little confused. But okay, let's look at it. I see this term has a variable, and I see this term has a variable. So I'm thinking back to my steps, and I'm thinking I want all the terms that have variables on one side. Meaning I'm going to take this and I'm going to transpose it over there. But also, I don't want this random constant on the side with my variables. So I'm also going to transpose that. What I get is I now get 6x minus x. Remember, when we transpose, we can take it over to the other side, but sign changes. Then I'll have 9 plus 3. Now, my steps said, once I do that, what was the next step? What's my next step here, you guys? I see Itandile has done it. She's not told us what it is, but the step is to add my like terms. And so 6x minus x is going to give me 5x equals to 9 plus 3 is going to give me 12. Now, I want to remove coefficients using inverse operations. So a coefficient means multiplication. Inverse of multiplication is division. That was my step said. But my step also said what I do on the one side, I must do on the other side. What happens here? My 5s cancel out. I'm left with x is equals to 12 over 5. Or you can convert this to a fraction to a decimal if you want. Run away. Okay. So that was our equations. I think there's one more for us to do. So I know we're like on time right now, but I do want us to finish up this one equation. And I'm thinking back to my steps. My steps said, okay, if there's brackets, first things first, we want to distribute. So 2 times x is going to give me 2x. 2 times negative 2, 100%, you guys, is giving me negative 4 equals to 10. I want to get my variable by itself. So the first thing I can do is transpose my negative 4. It becomes 2x equals 10 plus 4. 2x is equals to 14. Thank you guys for answering in the chat. My steps, what did my steps say? Let me think. Oh yes, my steps said when I have coefficients, I remove them with inverse operations. And so what happens now? My coefficient and my division cancelled out, but because I divided on this side, I had to divide on this side. And now my final answer is x is equals to 7. And so I'm going to try and find one we didn't do.
Bye, ma'am. Have a wonderful day, ma'am. Bye, ma'am. Good
You
night.
too, Liako. Bye.
Bye, ma'am.
Bye, ma'am.
Have a
Bye,
good
ma'am.
night. See you Thursday.
See you
You
Thursday.
Thursday, ma'am. Bye.
Bye. Okay. Oluthe, when you say you're confused with like plotting the points and drawing graphs, is this when they give you an equation and then they just tell you to draw the graph? Is that what you get confused by? We have to complete the table first. Okay, so I'm assuming this is something similar to what confuses you. So let's erase everything that I did here and let's complete this one together. So right now, we don't know anything except that they've given me an equation, which is y is equals to negative 2x plus 3. They've given me an equation. I'm going to try and erase this. They've given me an equation. Sorry, I'm like repeating the same thing. They've given me an equation, which is negative y is equals to negative x. No, y is equals to negative 2x plus 3. And they want me to use a table to draw the graph to represent this relationship in this equation. Now, you are 100% correct. We have to complete the table. But how am I going to complete the table now? What do I do here, Oluthe? What would you do? Let me know what you would do so that I can correct you.
The x, yes, the x
Mhm.
minus no. I think we times because like it's in a bracket. Negative 2 times x plus 3.
Mhm. Okay, so I hear what you're saying, but now you're telling me how to solve that equation. How is that going to help me with this table? I first need to figure out what my x values are before I can actually solve that equation. Do you see that?
Yes.
So, when you're given something like this and you have to fill in a table, what I want you to know is that you can pick your inputs, okay? Your inputs are your x values and you can pick them, but you must pick them super strategically. So, we always kind of want to have negative numbers as our input. You will want to have 0 and you will want to have positive numbers as your input. So, the safest option is always to make your inputs something like negative 2, negative 1, 0, 1, and 2. Does that make sense?
Yes.
Now, why we pick these strategically is just so that we can get a full range of answers from our equation as our y values, just so that when we're plotting the points, they actually create like a proper line. It's not all just going to be in one quadrant. So now that we've gotten that out of the way, now that we have these inputs filled in, now what do we do, Oluthe?
Negative 2. We're solving the table, right?
Mm-hmm.
Yeah. So it's negative 2 times negative 2
Mm-hmm.
plus the 3.
Beautiful.
Read, read when we to calculate it.
Mm-hmm. Let me know what answer you're getting here.
Seven.
So it's negative, negative, positive 4 plus 3. Beautiful. It's going to give us 7. So I can fill it in here, right?
Then negative 2 times -1
Mhm.
plus 3, which is +5,
Mm-hmm.
and -2 times 0 plus 3 is 3
Mm-hmm.
positive, and -2 times 1 plus 3 is 1.
Mm-hmm.
-2 times 2 minus, no, plus 3 is -1.
Beautiful. Okay. So now we've completed the table, and now, Olusle, what are you thinking? What are we going to do now?
We start with the x
Mm-hmm.
on the cross thing. We find the 7. There's no 7 there, man.
Okay.
-7.
So the first thing I want to tell you is, once we've completed our table, the best option, if you find this hard, the best option is always to write out your coordinates, okay? Because once we have a table, we need coordinates, and coordinates are always in the form of x and y. So I want you to tell me, when my x is -2, what should my y be?
7.
Beautiful. When my x is -1, what should my y be?
5.
5. Tell me the next coordinates. What would you write?
0
Mm-hmm.
and 3.
Mm-hmm.
Then 1
Mm-hmm.
and 1.
Mm-hmm.
2
Mm-hmm.
and -1.
Okay. So now we've written out our coordinates. Okay. Now my life is easier. I can just leave the table because I now have all my coordinates. Okay. Now what we're going to do is we must remember that all of these values here in my coordinates on the left, all of the values that are on the left are my x values, and all of the values on the right are the y values. So we always look for our x value first. So remember, this over here is my x-axis, this is my y-axis. So we are going to look for -2 on my x-axis, and my x-axis has a -2 over here. Now remember, if you look at the scale that we used, we counted in twos. So we might not have a -7, but what you should remember is that a -7 would be right in between that. Does that make sense?
Yes.
Cool. So we've found -2, but now we need to find +7 on my y-axis. And my +7 would lie somewhere just in between here. Do you see that?
Yes, ma'am.
Now what we want to do is we literally go and draw a dotted line, and we match up those points. And this is now going to be the first point that I draw. Does that make sense?
Yes.
Cool. And that's a little bit high because the point was supposed to be right in the middle. So there, that's a better point. And now let's do the next one. So I'm going to look for -1 on my x-axis. Now, there is no -1, but I know because of the scale I've used, my -1 is going to lie somewhere right around here. Do you agree with that?
Yes.
And I'm also looking for +5. And +5 is going to lie here. Do you see that?
Yes.
So we join up our lines and you'll get a dot right over there. Then we're looking at our next coordinate. We're now looking at 0 on my x-axis. 0 is going to take me right here in the middle. And I'm looking for +3. +3 is going to be right in the middle here. Do you see that?
Yes.
So my point is going to be here. And now we're going to follow the same thing for my other points. I'm going to do those ones a little bit faster. It's going to be +1 and +1, which is going to give me a point somewhere right about here. And then for my last point, I'm looking for positive 2 on my x-axis, which is going to be this first marking that I've made over here, positive 2, and then negative 1 on my y. And so that's why I erased it, because negative 1 is going to be right in the middle, and that is going to give me a point somewhere around here. And now once we do that, the only thing left to do is take a ruler, which I do not have, and you're going to try and join up your points as best as you can. And you should see that it gives you this straight line. Does that make sense?
Yes, now I understand now.
Okay. Anything else that you want to go through?
No, ma'am.
Okay.